talking about what refers to as the principle of conservation of momentum. Principle of conservation of momentum. Said in an isolated system, no external force, that is, no in an isolated system that is having no external force, the total momentum before the interaction equals to the total momentum after the interaction. So after the interaction, after the collision, the total momentum before will be equals to the total momentum after. The momentum is always conserved. So we're having the m1u1 of the first body plus m2u2 of the second body after before the collision. Then after the collision, m1v1 plus m2v2. So you can see this holds true for all type of collision. This holds true for all type of collision. Now let's look at some types of collision that we have. One, we have elastic collision. So in elastic collision, the momentum is conserved. So these are to identify maybe this is an elastic collision or not. One, the momentum will be conserved. Two, the kinetic energy is also conserved. Example, you have a billiard ball, or another example, you have gas molecule. So in a gas molecule, the collision that is happening between them is an elastic collision. Another we have inelastic collision. This inelastic collision also, the momentum is conserved. The kinetic energy is not conserved compared to that of elastic collision. Here kinetic energy is not conserved. So some are converted to heat, sound, and other form of energy, etc. Example, you have the clay ball sticking together. Clay balls sticking together. So when the clay balls stick together, the kinetic energy is no longer conserved. And we have another example, another type, which is perfectly inelastic collision. Perfectly inelastic collision. You shouldn't get this thing confused. We have the elastic collision, the inelastic collision, and perfectly inelastic collision. Here the two bodies stick together after the collision and they move as one mass. You can see the difference. The two bodies stick together and now they move as one mass. Two, the momentum is always conserved, we know that, but the maximum kinetic energy loss occur here. There will be a great loss in the kinetic energy.